Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video demonstrates how to use the range rule of thumb. Let's get started. In the previous mini lecture, we learned about the range and the range rule of thumb. Let's now return to our chocolate chip cookie example to illustrate how the range rule of thumb actually works. First, we know that the mean is 23.4 and the standard deviation is 1.7. What then are the minimum and maximum usual number of chips to expect in a chocolate chip cookie? Well, the minimum usual value is the mean value minus 2 times the standard deviation. So 2 standard deviations is 2 times 1.7, which we then subtract from the mean value of 23.4 to get 20. That is our minimum usual value. We can find the maximum usual value the same way, only we add instead of subtract. This gives us 26.8. So this means that we can expect the usual number of chips to be between 20 and 26.8. If a cookie has less than 20 chips or more than 26.8 chips, then that cookie is unusual. So when you're asked, would a cookie with 30 chocolate chips be unusual, and why or why not, it should be clear what the answer is. So what is it? I'll give you a few seconds. Well, I hope you said it would be unusual because 30 is more than 26.8, which is the maximum usual value. Now, you MyMathLab users may see a question like this in your assignments asking about the error in estimating standard deviation. So let's go over how to answer it. First, we're going to have to calculate an estimated standard deviation. We do that by calculating our range of usual values, which is our max usual value minus our min usual value. We then divide that difference by 4. This gives us an estimated standard deviation of 1. We know our actual standard deviation is 1.7 because we're told so, and we calculated it in an earlier mini lecture. So all we do now is whip out our error equation and plug and chug. When we do, we get 41.1%. This is our percent error. Let's look at another example involving the POTUS file you should be quite familiar with by now if you've been participating in the previous mini lectures of the course. An analysis of the heights of U.S. presidents has produced the values that you see listed in the results shown below. Now the question is, does the range rule of thumb produce an acceptable approximation for standard deviation? Consider the approximation acceptable if it has an error below 15%. I think 15% is pretty large for acceptability, but hey, I'm not the one that wrote this. So, well, okay, let's think about this. Before we can assess whether an approximation is good enough, we need to make that approximation, okay? So, first, let's make the approximation, okay? And we're going to use the range rule of thumb to do it, okay? Our range is 36, okay? Which, when we divide by 4, gives us an estimated standard deviation of 9. Nope, we got that 36 from our results table over here, okay? The next step, once we have our estimated standard deviation, is to calculate percent error, okay? We do that using our handy-dandy percent error equation here. So we substitute our values in the equation, and notice that this actual value right here, okay, we're getting from our results table over here, okay? And of course, this estimated value of 9 comes from our estimate that we made just a moment ago. We punch all this out on our calculator, okay, and then out comes 7.41%. We're told to consider the approximation acceptable if it has an error below 15%. So is that what we have here? Well, we certainly do. So 7.41 is less than 15, and that means, yes, this is an acceptable percent error. Now, would living 30 years after being elected to office being unusual in a U.S. president? Pause the video here, go get your answer, and then come back so we can talk about what you found. Okay, let's take a look at this. We first would need to know the range of usual values. So if 30 years is inside that range, then it's what it would be usual or expected. And if it's outside that range, then it would be unusual. So first we need to calculate the minimum usual value, which is x bar minus 2 standard deviations. Notice the S here is the estimated standard deviation using our range rule of thumb. The mean value of our data set is 15.03, which we see here in our results table. Then we subtract 2 times our estimated standard deviation. This gives us a mean usual value of negative 2.97. Now, don't freak that this value is negative. There's nothing wrong with that. All it says is that anything less than that would be unusual. And that's true. A negative value for the number of years would be unusual. That's what we expect to see. Now, some of you may be thinking, what about the values between negative 2.97 and 0? Negative values that will be quote-unquote usual. Well, if you ever see them show up, you can call them usual. I'm not holding my breath for that, though. But hey, if you do see those values show up in reality, let me know. We can make some real money together. Okay, the maximum usual value will be x bar plus 2 times our estimated standard deviation. So when we punch that out on our calculator, we get 33.03. Because 30 is inside this range of usual values, we conclude that living 30 years after, being president would not be unusual. So once you get your min and max for your range of usual values, it's easy to answer questions like this. You just look to see whether you're inside the range of usual values or outside of it. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.